Okay, so welcome back to another Physical Science 3 lecture. In the last lecture, we finished off the velocity versus time examples. And then this one, we're going to use velocity versus time to start off with, for velocity versus time graphs to get the acceleration versus time graphs. So we just remember that we need to calculate the gradient for those. So we have here a gradient of 0. So we just need to draw in our 0 line, these ones. And we'll just make it so each box, I think, is probably need to get my drawing out. Oh, it is working. Oh, I said doing one of those things again. I know, it's actually drawing. Okay, so I haven't got quite on the line, but it's 0. So the gradient is equal to 0 there. Now let's have a look at this one here. This is the same velocity versus time graph we had before. So this here is roughly 5 at 0, and then this is our point 10, 25. Okay, so just remember, if you've done a bit of maths, you can calculate the gradient this way. So it's y2 minus y1 over x2 minus x1. So that's the same as rise over run. So we've got 25 minus 5 over 10 minus 0, which is equal to 20 over 10. It's equal to 2. And it's constant, meters per second. Okay, squared. Meters per second squared. So let's draw in our... So again, we've got our axis. Okay, so that's our 0 line. 1, 2 for our acceleration. So for the first, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so it's just going to have to be here is 2, 4, 6, 8, 10, and 12 seconds. So those don't quite line up. So it goes for 10 seconds, and it's just at 2 for all these times. And we've got our line. Oops, not quite at the same spot. It should be at 2. Maybe you can draw it better on your graph. So this would be -1, -2. If we're going to label them a bit more. Okay, good. Okay, so this one again is just a constant gradient. A equals, let's just do the rise over run this time. We did these before. So it goes down 20. So it's a -20 there, and it runs for, what does it run for? 5 seconds. So A is equal to -20 over 5, which is equal to -4 meters per second squared. Okay, so hopefully you're seeing that for straight lines, it's just a constant line across. So let me see. This is again our 0 line across there. 0, and then we've got -2, -4. This is 2, 4. So then this will be our, and it goes for 10 seconds again. So we've got 2, 4, 6, 8, and 10. There we go. So it's just a straight line across. Okay, so this one's a little bit more interesting. We've got 2 gradients here. So we've got 1 and 2 segments. For 1, A is equal to, our rise is 20 over 4. So our run is 4, so that's equal to 5 meters per second squared. And then it should just be the opposite for the next one. So it goes from 20 down to 20 down to 0, sorry, over 2 seconds. So for 2, A is equal to -20 over 4, which is equal to -5 meters per second squared. All right, and so we just need to draw that into our line this time. So let's just do, if this is our 0 line across here, I'll just go up in 2 by 2s again. So that's our 0 axis. It's our time axis. A is equal to 0. Go 2, 4, 6 up here, and 2, 4, 6 down there. So for the first 4 seconds, so this is going to be 2 and 4. And then we're going to have 6, 8, 10. Okay. So for the first point, we go from here to 4 seconds. So it's going to be there and there. Something like that. So that's at 5. And then because there's an immediate change down here, goes to this point there. So this is our 5 point for here and here. Just draw a straight line across like that. Okay. So that is -5. Oops, and I forgot to put the negatives in there. Okay, so that's the first lot of just acceleration versus time graphs. So you just calculate the gradient and you just draw them in. It looks a bit strange, especially this graph looks a bit strange. Probably something you haven't really seen before, but it immediately changes from an acceleration of 5 meters per second squared in a positive direction to 5 meters per second in a negative direction, and that's why we get this instantaneous change in the graph like that.